Okay. In limits, so we discussed that this function is equal to this function except at this point. There is a hole here. And so that's why we define limit of this function when x approaches 1 is 2.
Yes,
Okay?
sir.
Okay. So be careful while looking at the graphs. When x is approaching 1, y is approaching 2. Agreed? X is
Yes, sir.
approaching 1, either this side or this side, y is approaching 2. Okay? That's why we call the limit as 2. Okay. In this case, when x is approaching 1, y is approaching 2, but uh, the value of the function is not defined. In this case, the value of the function is defined as 1. Agreed. See
Okay.
the difference between this and this. What is the difference? Here the value of function is defined as 1, which is not equal to 2. In this case, the value of the function is also 2. These are three different cases. Agreed?
Yes, sir.
In all the three cases, limit extends to 1 is 2.
2.
Okay. But in this case, f of 2 is 1. In this case, f of 2 is not
Not
defined. Sorry, f of 1 is not defined. In this case, f of 1 is 1. Okay.
okay.
In this case, f of 1 is 1. But limit extends to 1 is
Approaching 2.
limit extends to 1 is 2. Okay. In all the three cases, limit is 2. When x tends to 1, we are approaching when as we are going towards 1 on x-axis, we are tending towards 2 on y-axis. Okay.
Yes.
Okay. Very good. Now, constant function, it's always constant. That's why there is no problem of limit, right? Wherever you are always approaching a k only, whatever is this constant, right? Now here, let's say there is a point here. Point is, let's say x equals to 2. What is the limit at x equals to 2?
1.
1. X equals to 3?
1.
1. X equals to 0?
1.
Why 1? Are you approaching 1 when you are approaching 0? That is the
No.
question. What are you approaching? When
0.
you are approaching 0 on one side and 1 on the other side, right? So what exactly you are approaching? Are you approaching 0 or are you approaching 1? When x is getting closer to 0, so when x is getting closer to 0 means there are two ways of getting closer to 0, right? One is from the left side, another is from the right side, right?
Yes, sir.
Agreed. When x is approaching 0, then what is y approaching? Is y is approaching 0 or y is approaching 1? Basically what is the value of function happening? When you are inputting x as -2, -1, -0.5, -0.2, whatever. What is the value of the function approaching? Is it 0 or is it 1?
0.
We cannot say no. See, when you are approaching from negative numbers,
Okay.
the value of the function is approaching 0. Or in fact, it is always 0. Okay. The moment you cross 0, the value of function is always 1.
So
Right.
you cannot say.
So we cannot say. Okay. So at x equal to -5, the limit is 0. X equals to -4, limit is 0. -2, limit is 0. X equals to 2, 4, 10, limit is 1. But x equal to 0, you cannot clearly say. Understood the difference?
Yes, sir.
Okay. Difference between x equals to 2 and x equals to 0. You tell me what is the difference?
That x equal to -2 or anything negative,
Hmm.
it's approaching to 0.
Hmm.
Anything positive, it is approaching to 1. But
Right.
exactly at 0, you cannot tell.
You cannot tell. Okay. Because we are not clear. We cannot claim whether it is 1 or 0 because there is a confusion. Okay.
Yes.
Similarly, this one, when x equals to -2, let's say, there is this number. Okay. X equals to +4, there is this number. But when x equals to 0, what is happening?
It's not approaching any
It's
value.
not approaching any number. One side you are approaching some number, another side you are approaching some number, so you cannot clearly say. Okay. So here, let's say x equals to 10, you are approaching some number. X equals to 5, you are approaching some number. X equals to 2, you are approaching some number. X equals to -10, you are approaching some number. What about when x is approaching 0? Here,
You're not approaching.
x is approaching 0, we are not clear because this function is actually, this is sine 1 by x. Okay. When x is approaching 0, 1 by x is approaching infinity. Right?
Yes, sir.
Okay, and sine is a periodic function, right? Sine 2
Yes,
pi,
sir.
sine 4 pi. But 1 by x, it increases so rapidly when there is a small change in x, right? Let's say, for example, 1 by 10 versus 1 by 11, or this one, right?
Hmm.
1 by 10, what is 1 by 10? 100.
Yes, sir.
Sorry. 1 by 10 is
One.
1 by 10. X
So
is
what?
10. X is 10.
Okay.
So when x is becoming big, 1 by 10 is zero point 0.1.
Hmm.
Okay. When x is 1 by 11, it is 1 by whatever. It is around zero point 0.1. Right. When x is becoming big and big, what is happening? 1 by 100 or 1 by 1000 or whatever, this is almost becoming zero, sine zero.
Yes, sir.
Right. Sine 0, if you further draw the graph, it will come like this, like this, like this. Sine 1 by infinity. That becomes sine 0. So that is fine. I'll show you another. I'll show you. Just give me a minute. Can you see my screen, ma?
Yes, sir.
Okay. See here. When x is becoming big, 1 by x is becoming small. Agreed?
Yes, sir.
When x becomes like 100 or 1000, whatever, 1 by x becomes almost 0. So sine 0 will become 0. Okay. When x is tending towards infinity, this graph is approaching towards 0. Agreed?
Yes, sir.
When x is approaching minus infinity, then also the graph is approaching 0. When you say graph is approaching 0 means the y value is becoming 0. The result of the graph. When you substitute x as something, you get some result, right? The value of the
Yes,
function.
sir.
Value of the function is getting closer to 0, right? But when x is getting closer to 0, what is happening? This is fluctuating a lot. Why it is fluctuating a lot? Because, say for example, 1 by zero point 0.4. Okay, this is some number. 1 by zero point 0.2. This is much bigger number, right?
Yes, sir.
1 by zero point 0.1, that becomes 10. 1 by zero point 0.01, that becomes 100. So, a small change is amplifying this graph multiple times. Why it is this happening? Because this is a sine graph, right? Sine repeats itself after every 2 pi.
Hmm.
Okay. Now, sine 1 by zero point 0.4. What does that mean? Sine 2.5. That is slightly lesser than sine 2 pi, right?
Yes, sir.
That is in fact less than sine pi. Sine pi is sine 3 point something, right?
Hmm.
Now 1 by zero point 0.4. 1 by zero point 0.2. What is this? This is actually equal to 5.
5.
1 by zero point 0.2. 5. That is actually slightly less than 2 pi. 1 by zero point 0.1 if you do it, right? It becomes sine 10.
10.
Agreed? Sine 10. So, and even after that, if you slightly reduce, right, the sine will complete the cycle multiple times.
Hmm.
Understood what I'm trying to say?
Yes, sir.
Between zero point 0.1 and let's say 0.01, there will be a lot of 2 pi's. Right?
Hmm.
If you do 1 by zero point 0.1 versus 1 by zero point 0.01. Okay, there will be a lot of 2 pi's, right? In that
Yes, sir.
multiple, in that distance. Agreed or
Yes.
not?
Yes, sir.
Okay, so because there are a lot of 2 pi's in that distance, the cycle will be so many.
Hmm.
You understood what I'm trying to say?
Yes, sir.
Okay, because there are a lot of 2 pi multiples between, let's say 1 by zero point 0.1. 1 by zero point 0.1 is 10.
10.
Okay, 10 is roughly some 3 pi, right? 3
Yes.
into 3. And between, let's say 1 by zero point 0.01, that is 100. Agreed?
Yes, sir.
So there will be some 30, so some 15 2 pi's or something, right? 15 6. 2 pi is 6 point something, right?
Hmm.
So between zero point 0.1 and zero point 0.01, it would have got some 15 cycles. Okay.
Okay.
Between zero point 0.01 and let's say 0.001, there would have been another 30 cycles or 40 cycles, whatever. Okay. So as your x value becomes smaller and smaller, the number of cycles will increase very rapidly. Okay. Like
Okay.
this. Okay. Agreed.
Yes, sir.
Number of cycles are increasing so rapidly. Okay.
Yes, sir.
Now, because they are increasing so rapidly at x, when you are getting closer to x, closer to 0, the cycles are increasing rapidly. So we cannot clearly say at 0 whether it is zero point 0.4. The value of this expression is 0.4, 0.8 minus 0.4. We cannot say. Understood?
Yes, sir.
So that's why we say sine 1 by x, the limit does not exist. Okay, this is important result. Okay, just
Okay, sir.
remember sine 1 by x, the limit does not exist
Hmm.
because we use this result in multiple forms. Okay, we use a slight different variation of this result also in different forms. Okay,
Okay.
okay. Now coming back here the limit does not exist. Agreed?
Yes, sir.
Here also at 0 it does not exist. Here also at 0 it does not exist. Here also it does not exist.
Exist.
Okay, it does not exist. When we discussed about some limits, we said the function approaches whether the value of function is there or not, it doesn't matter. If the function is approaching some number, then that is the limit. We discussed that. Right.
Yes, sir.
Now let's say there are two different functions.
Hmm.
Okay. Two different functions. They are approaching certain numbers.
Hmm.
Okay. There is a function. This is approaching let's say this value is 3, and there is a function. This is approaching, let's say this value is 1. Okay, the function need not be defined at this particular value. Let's say this is at 5. F of 5 is not defined, but limit extends to 5. This is 1 and this is 3. Agreed? The point I am
Yes.
trying to say, if it is defined, well and good, then we can directly say f plus g is this 1 plus 3, whatever, right?
Hmm.
This is 1, this is 3. If the function is defined, there is no problem. Now, the point is, even when the function is not defined, if this function, let's say it's f is approaching 1, this g is approaching 3, then what we say, f plus g is approaching 4. Okay,
F plus G is approaching.
3 plus 1, 4. Okay,
Huh. Huh.
okay. If it is continuous and if it is defined at f of 5,
Hmm.
then that is fine. Okay. Generally, so far we have discussed about functions which are defined at all points where we are adding.
Yes,
Okay.
sir.
Okay, but now even if they are not defined, this extends to the places where it is not defined also. As long
Okay.
as we are certain that this function is approaching 1, okay, and this function is approaching 3 at x equals to 5, we are certain that at x equals to 5, if we add these two functions, the resultant is a new function, right? That
Yes,
will
sir.
approach 4. Okay,
Okay.
okay, so that is basic, it looks commonsensical, right?
Hmm.
Okay, so similarly, we are just talking about limits. These limits, this sum or difference or product, whatever, they all follow normal addition subtraction rules.
Hmm.
Okay, so if you take the power, so we don't know. Basically, why it is important is at this point we don't know. If we cannot directly substitute f of 5.
Yes,
Okay,
sir.
we cannot directly substitute f of 5, but we by some manipulation we can say limit extends to 5 is actually 1. Okay,
Hmm.
or by some manipulation we can say it is approaching 3, but we cannot directly get 3. Even in that case also, if you do some manipulation, algebraic manipulation on the function, that value will actually behave in the same way. Okay, so for example, limit extends to f of x whole power n. We don't know what is f of c, but doesn't matter. Okay,
Hmm.
f of c, f of x is approaching some value. Okay, let's say that the value is n. Then if you raise the function to n times, then that value will also will get raised. Okay, ma?
Yes, sir.
Very basic rules. Okay, okay. So these are direct substitutions, right? You know these substitutions, right? X tends to c whatever. Okay, as long as the denominator is not 0, we can directly substitute. Okay,
Yes.
okay. Then okay, this we discussed, right? What is the
Hmm.
limit of this function at x equals to 1? It is actually 3.
3.
But we cannot directly substitute 1. Why? Because the denominator is becoming 0. So what do? When
Rationalization.
denominator is becoming, we remove a common factor. So
Common.
whenever something is becoming 0, that means there's a hidden common factor there. Okay.
Yes.
X square minus x is becoming 0 at x equals to 1. That means x minus 1 is a something hidden there. Okay. We have to remove that x minus 1. Then we'll get a simpler function. Okay. Now this one, see, x tends to 0, this one. Okay. Now that means x minus 0 or x is a common factor both in numerator and denominator, because numerator is also becoming 0, denominator is also becoming 0. Once you remove that common factor, you will find out what is the limit. Okay?
Yes, sir.
Okay. So what you are doing, you are rationalizing the
Rationalizing.
numerator. Okay. So now the hidden common factor in the numerator is also exposed now. Okay. That we are cancelling both and we are getting the limit. Okay. Now if you plot the graph of this, okay, most likely you will see at x equals to 0, this function is approaching this value. Okay, most likely. Okay, but at 0 you cannot directly calculate the value. F of 0 is not defined, but still if you plot the graph, both from the left side and right side, you will be approaching this number. Okay, we discussed about sandwich theorem. What is sandwich theorem? When a function is lying between two different functions, okay, and both the functions are approaching some number, obviously the middle function will also approach that number.
This
All
same.
three, right, same number. Okay, but these functions need not be defined at that particular value, right? F of 0 is not need not be defined, g of 0 need not be defined, h of 0 need not be defined. Just that we are saying that all three approach that number.
Yes.
Okay, very good, fantastic. Now we discussed about this. Okay, x equals to 1. What is the limit?
1.
1 or 0? Be careful. So
Sir,
here
0.
0 or 1 are not defined. Be careful. Okay, first tell me what should you do? What all things you have to observe? X is approaching 1. Okay? Okay, be careful. When x is approaching 1, what does that mean? X can approach from both sides, right?
Yes, sir.
Okay? And y is approaching. That means what is value of function happening? Value of function is becoming what? When you are approaching from both sides. From the left side, if you are approaching 1, what is the value of function?
From left side it is 0.
Left side, you are approaching 1. Okay, so when I say don't get confused, when I say approaching, there are two approaches. One is approaching x, okay? Well, so that means basically when you are substituting, let's say 0.5, 0.6, 0.6, 0.7, 0.7, 0.8, 0.9. Okay, that is left approach. What is the value of the function?
1.
Po- 0.5 is 0.5, 0.6, 0.7, 0.8, 0.9, 1. Okay,
It's approaching
that's
1.
approaching 1. Okay, when I am saying left x is approaching 1, what does that mean? What is y approaching? What does that mean? What is the value of function becoming when you are inputting values of x coming from the left? Okay, when you are inputting values of the x coming from the right. For example, 1.9, 1.8, 1.7, 1.2, 1.1, 1. What is the value of function that you are approaching?
1.
Why 1?
Sir, when you're inputting the values,
Okay,
you're
okay.
getting
You tell me. F of 1.1 is how much? F of
1.
1.9 is how much?
1.9 only I'm
F of
saying.
1.5 is how much?
1.5.
F of 1.1 is how much?
1.1.
Why 1.1? See careful. See, f of 1.9 is, what is this value? This is zero point 0.9. F
So
of
it's approaching
1.5 is,
2.
this is, no, no, no. See, you are approaching from the left hand side, from right to left. Okay, you're approaching from right. What is f of 1.9? Tell me again.
1.9.
No, no, no. It is zero point 0.9. Okay, this is f.
Okay, understood, sir.
Okay, f of 1.9 is how much?
Point 0.9.
F of 1.5 is how much?
Point 0.5.
F of 1.1 is how much?
Point 1.
F of 1.01 is how much?
Point 0.01.
0.01. So f of 0.99 is how much?
Point 0.99.
Okay, so now when you are approaching x from one side, you are getting 0.99 and 1. When you are approaching x from the other side, you are getting 0, zero point 0.1 and all. Agreed? Agreed? Now
Yes, sir.
both numbers are not matching, no?
Yes, sir.
You understood? That's why the limit is not there.
Not if not
Okay?
there.
Now you have to approach 2. Okay? What are the various ways of approaching 2? Tell me.
From 1 and from 3.
From 1 and from 3. When you are approaching 1, you tell me what is the value of function becoming?
2.
F of 1.5 is 1.5. No, no. Why is it 2? Be careful. When you are approaching from 1, why are you getting 2?
Sir, my doubt is, do you approach down to up or up to down?
No. So when I say approach means x is approaching this thing. Okay. What is
Okay.
f of x happening? What is the value of function becoming? Okay.
Hmm.
Your approaching means you are inputting values of 1.1, 1.5, 1.7, 1.9 in the function. What is the value of function becoming? Let's say you are writing a tabular data.
Okay.
Okay, data. You are writing tabular data like this. When you are approaching 2, that means what is f of 1.1, 1.5, 1.9, and 1.99. Okay.
Zero
What is the
point 0.1, 0.5, 0.9.
0.9? Okay. This is what approach. This is you are approaching 2 from the left hand side. That means
Okay.
something from lesser than 2 to 2. Okay.
Hmm.
Now, similarly, if you approach 2 from the higher side, that is 2.9, 2.8, 2.5, 2.2, 2.1. Okay. Now, what is the value of function becoming?
0.29.
Zero point 0.9, zero point 0.8, whatever, zero point
Hmm.
0.1. Okay. So, be careful. 2.9, what is the value of function? 2.9 is 0.9. Okay. 2.8 is
0.8.
0.8. Okay. Right. 2.1 is,
Zero point 0.1.
wait. So be
So
careful.
0.29289.
Wait. 2.9. What is f of 2.9?
0.29.
F of 2.9. That is this. That is this. Okay. That is roughly zero point 0.1, right?
Hmm.
Understood. This is zero point 0.2. This is zero point 0.5. Agreed? We
Yes.
are telling the reverse. Okay. As
Okay.
as it is becoming 2.1, this is becoming zero point 0.9. Agreed?
Yes, sir.
Okay. If you are approaching 2.9, okay. So, or I will put it in the reverse only. Okay. 2.9. Yeah, you can approach it like this, right? 2.8,
Yes.
2.7, 2.3, 2.1. Now tell me what is the value of 2.9?
0.9.
Why 0.9? Just see. 2.9 is here. Okay. What is the value of y when x is 2.9?
0.1.
0.1. It is not zero point 0.9. Okay. That's
Hmm.
what we have to be careful. Okay. This is 2.9. This is zero point 0.1. Okay, ma.
Yes.
This is zero point 0.1. At 2.8, this is zero
0.2.
point 0.2. This is zero point 0.3. This is zero point 0.7. This is zero point 0.9. Understood?
Yes, sir.
Okay. Now what is happening when you are approaching 2 from the left hand side? That is from lower values of 2. You are approaching 1. Okay. This is becoming
Hmm.
1. When you're approaching 2 from higher values, then also you are approaching 1. Understood?
Yes, sir.
Okay. So when approaching from higher values, then also you are approaching 1.
So
Agreed?
at 2, it is approaching 1.
At 2, it is approaching 1. So basically what we are trying to say is this is also this. So that's why this is this. Okay. That is what we are trying to say.
Okay.
Okay,
Understood.
here we are trying to say this is this, both are not matching.
Okay. Okay,
Okay,
sir.
okay, here we are trying to say this is this, so that's why both are matching. Understood?
Yes.
Understood. So now tell me, what about this? X tends to minus 2. What is value of function? But
So
we are
from
trying to say
left.
this is this, right?
Hmm.
We are trying to say that.
From left, when it is approaching
My,
minus
when is
2,
minus 2, what is value of y? What is the value of function?
0.
0, exactly. Okay, the y is becoming 0. Left side you are approaching minus 2. That means y is becoming 0. Okay?
Hmm.
Okay. What about right side?
Again 0.
Again 0. So what is the limit?
0.
Excellent. Okay. This is excellent. Now, okay. Now tell me when x is approaching minus 1. Okay? Agreed? X is approaching minus 1. Now what is y approaching?
-1.
-1. Both sides it is -1. Okay?
Yes, sir.
Okay. Now when x is approaching 0. So what are we talking about? This one. This and this.
Not defined was
Not,
from one side -1, from one side 1.
yes, that's why it is not defined. Agreed?
Yes.
Okay. Now see here, when x is approaching -1. This and this. What is the limit?
0.
0. F of 0 is 1. It doesn't matter. Okay?
Hmm.
Now x is approaching 1. You should tell me. X is approaching 1. What is y approaching? One is this. What is the opposite side?
The opposite side?
X is approaching 1, no?
Yes, sir.
This is 1. And the x is approaching this side. There
Hmm.
is another side, right? That is
Yes,
this,
sir.
right? So what is the limit?
1.
Why 1?
Because from both sides it is approaching at 1.
Where,
Why,
where,
why?
where? Where is it approaching? Left hand side, where is it approaching?
Left hand side, sir, the below part of the graph,
So it is
it is
approaching. No, no,
approaching
no,
1.
don't get confused. When you say it is approaching, this is approaching this -1. Okay, that is approaching this 0. Understood?
No different, so not
So
defined.
you should not get confused between x and y values.
Huh.
X is approaching 1. What is y approaching? Y is
-1.
approaching -1, no?
Hmm.
Here x is approaching 1. What is y approaching?
0.
Y is approaching 0. So that's why,
Not defined.
that's why it is not defined. Okay?
Hmm.
Okay. Now here, when x is approaching 0, be careful. Take your time. When x is approaching 0, what is happening?
Sir, two different values.
Why two different values?
One is approaching 0, it is becoming -1.
No, no,
Another
no.
one,
Wait. It is becoming 0. Where? It is becoming 0. That is this.
hmm,
Okay. What is the other side?
the right part.
Right one. What is the approach? It is this only, no?
Hmm.
Understood.
So, since both are approaching 0,
This is also approaching 0 only.
hmm,
You're getting what I'm trying to say. This is also
yes,
approaching 0. This is also approaching 0. Okay. So that's why the limit is 0 only. Okay. At 2, what is it approaching? And at x equals to 1. Okay. And just write it. X equals to 1. What is, you write it. Then you will get you will get clarity. Okay.
okay,
When x is approaching 1. Okay. X is approaching 1. What does that mean? You have two approaches. One is lesser than 1, another is greater than 1. Okay.
yes.
When x is approaching lesser than 1. Okay. Then tell some values, rough values.
One, it is approaching from -2.
What is when x is approaching 1? Okay. What are the two ways of approaching? Two ways of approaching. One from left, one from right.
Yes, sir.
Okay. One from left means one from, let's say, something lesser than 1, and right means something greater than 1. Okay. Now
Okay.
take 4 values of x which are lesser than 1 in
3,
ascending
4 values which are lesser than 1.
order. Which are lesser than 1. Tell some 3, 4 values.
Point 0.5, point 0.3, point
Point.
0.2.
No. Still in ascending order.
Point 0.2, point 0.3, point 0.5.
Point 3, point 2, point 5, and point 9. Just try to approach one. Okay. Closer
Okay.
the better. Okay. Point 2, point 3, point 5, point 9. Okay.
Hmm.
Now what is f of point 2?
F of point 2.
Hmm.
Point 2 itself.
Why is point 2? What is f of point 2? Is it positive or negative? Where you have to look at the graph. F of point is how much? F of point is this value, no?
Minus point 2.
Minus point 2. What is f of point 5?
Minus point 5.
Minus Minus point 5. What is f of 0.7?
Minus 0.7.
No, no, no. It is actually, it is crossing 1. Minus 1 point something. Okay.
Okay.
Okay. F of 0.9?
Minus 1.9.
Minus 1.9. Okay. That is fine. Now, what is the other way of approaching x? X from higher numbers.
Higher numbers.
Okay. Take some 3, 4 numbers in descending order now.
2,
Which
1.9, 1.5.
2, 1.9, 1.5, and try to approach 1. 1.1 also.
Okay.
Okay. What is f of 2?
F of 2 is 1.
F of 2 is 1. F of 1.5?
0.5.
0.5. Okay. F of 1.1?
0.1.
0.1. Very good. So f of 1.1 is 0.1. Okay. Now, and f of 0.9 is how much? We have written
Minus.
minus 1.9. So are these numbers coming closer?
No.
They are not coming closer, no?
Yes, sir.
Okay. So graphically, what is happening when you are approaching 1? X is approaching 1. Okay. When x is approaching 1, y is approaching minus 2. Agreed.
Yes, sir.
Y is approaching minus 2. Agreed. When x is approaching 1, y is approaching what? 0.
0.
Y is approaching 0. So this one is happening like this, the other is happening like this. Okay. So one is here, another is here. Okay, both are not matching. Understood?
Yes, sir.
Okay, that is the trick here. Okay. Now, okay. So this one, limit x by
Mod
this
X.
one, mod x. Okay. When x is greater than 0, what will this become?
Positive. No.
When x is greater than 0, what is mod x? Is it x or minus x or plus x? What is this?
X.
It is x. So x by x will become 1.
1.
Agreed?
Yes, sir.
When x is less than 0, what will this become?
Minus X.
Minus x. So x by minus x will become minus 1.
Minus 1.
Okay. So what does it mean? What is the graph of this function? The function, as long as x is positive, it is 1. As long as x is negative, this is minus 1. Agreed?
Yes, sir.
Okay. So now what is saying? Limit x tends to 0. What is the limit? One is minus 1, one is plus 1. Is there a limit? One side you are approaching. Now tell me. What is the limit?
Not defined.
Not defined. Very good. When x tends to 5, what is the limit?
When X tends to 5.
5.
1.
1. X tends to minus 10?
Minus 1.
Minus 1. Excellent. Now what about this one? Limit x tends to 1, 1 by x minus 1. Okay. Okay. So here what you have to do, if you input some number like 1.1, what you are getting? You have to approach x from two different sides. Okay, what is the first side? We
Sir,
have to
I'm
approach
not
one.
able to hear you.
You have to approach one from two different sides. Okay, one from the left side, one from the right side. Okay.
Yes.
Okay. So then take some number which is closer to one from the left side. Let's say
From left side,
mm,
point 3, point 5, point 9.
point 3, point 5, point 9. Okay. If you input point 9, what is the value of this function? 1 by.
Sir, I didn't hear
If you
you.
input point 9, what is the value of the function? 1 by point 0.9 minus 1. Okay.
Yes, sir.
That is 1 by minus point 0.1. Right.
Yes, sir.
That is something minus 10. Okay.
Hmm.
If you are approaching from the right hand side, what is becoming? Let's say if you input a number x
1.1.
1.1. What is this becoming?
1.1 minus 1.
That is 1
Point
by
2.
point 0.1. So that is becoming 1 by 10. 1 by point 0.1, which is becoming 10. So left side, if you are approaching this is becoming negative numbers. Right side, you are approaching this is becoming positive numbers. That is one side of the story. Okay. Now, yesterday we discussed 1 by x graph is like this. Remember?
Yes, sir.
Okay. We also discussed if we know f of x, we also know f of x minus 1. Okay. What is this? This is horizontal shifting, right? Right side, 1 unit.
Yes.
Agreed? So I'll show you another. Can you see my sheet?
Yes, sir.
1 by x, 1 by x minus 1. What is happening here? 1 by x
Shifting
minus
of
1.
graph.
Shifting of graph 1 unit towards
Right.
right. So this blue graph is actually shifted 1 unit towards right. Okay.
Mm.
Okay. So now look carefully look at this blue graph. 1 by this is 1 by x minus 1, right?
Yes.
Now when x is approaching 1, okay, when x is approaching 1, that is this line, this black line. What is y
Mm.
approaching? One side you are approaching minus infinity, another side you are approaching plus
Plus
infinity.
infinity.
Agreed? So
Yes.
there is no limit here. Agreed?
Yes, sir.
Understood, no?
Understood.
Coming back to our set. Okay. This you are clear now?
Yes, sir.
Okay, you have to be little careful while doing this. Okay, so these are simple cases, right? So for example, if this is direct substitution, as long as the function is defined, it's easy for us. Okay,
Yes. Yes.
in these cases, we are directly substituting.
Mm.
Okay, in this case also, we can directly substitute. Okay, except this one. So here it looks like the denominator is becoming 0. Okay,
Mm.
and what about the numerator? Numerator is also becoming 0, right?
Yes, sir.
Okay, root of 5h plus 4. So what do you do in this case? You
Rationalize.
you rationalize. Why do you rationalize? Because there's a hidden factor of h minus 0 in the numerator also.
Yes.
Okay, we have to get that hidden factor exposed so that
Mm.
we can cancel that out and then find out what exactly is this value. Okay,
Yes, sir.
okay. Just try to do this calculation and tell me what exactly is the limit of this 20 second.
1 second.
What is the function square root 5h minus.
Sir, 1 second. Just 1 second, sir.
Okay, ma'am.
Sir, I guess I'm making some mistake. I'm not getting the key properly.
What have you done?
Rationalization.
You have rationalized, no? So you
Yes, sir.
multiplied numerator and denominator with what?
The positive of that, like root 5h plus 4 plus 2.
Plus 2 by this thing. Okay, so what is the numerator becoming? 5h plus 4 minus 4, right?
Yes, sir.
Okay, so that means what? You will be left with 5h in the numerator, right?
Yes, sir.
Okay, by h times of, again, root 5h plus 4 plus 2, right?
Yes, sir.
Then cancel out this h and h. That is what our goal was, right? We have to remove this common factor of h.
Sir, I didn't cancel that out. That's why I thought I was getting 0 again, so it's
Okay, okay.
bad.
No, so what is our goal? Original goal was this only, to cancel
Yes,
that out. Okay,
yes.
why to cancel? Tell me.
So that our entire value does not become 0.
Yes, yes, because we sensed that there is a common factor, right? So our goal itself is to remove that common factor. There is a
Yes,
hidden
sir.
common factor. We want to remove that common factor to get the limit.
Yes.
Okay,
Final answer will be 5 by 4.
5 by
4.
4 is it?
Yes.
Okay. 5 by 4 is 1.25, right?
Hmm.
Okay. Now I'll show the graph of this function. Okay. Can you see this graph?
Yes, sir.
Okay. So basically the function is not defined at this point. If you zoom it a lot, right, you will see a gap there.
Hmm.
Okay. But the function is actually approaching. Okay. When x is approaching 0, what is y approaching?
1.
Not 1. This value. This 1 point whatever that you have created, no? 1.25. 5
2,
by 4.
5.
Okay. When x is approaching 0. Okay. Are you able to visualize this? When x is approaching 0, that means what is y approaching? Okay. Are you
1.
convinced that y is approaching 1.25?
You can't be sure
No, no, no.
until.
Oh, graphically, you are sure, no?
Yes, yes, sir.
When x is approaching
0.
0, y is approaching what? The value of
1.2.
the function is approaching what? Forget about y. Value of the function is approaching what?
1.25.
Okay, give some examples. Let's say x is approaching from right hand side and from the left hand side.
Okay.
X is approaching, let's say, from the left hand side. Let's say zero point 0.7, zero point 0.5, likewise. Give some examples. What is value of function becoming?
So, sir, from left hand side when it is approaching point 4, point 3, point 2,
Ah,
all values it is like on the y side it is approaching 1.25.
1.5. So x of zero point 0.5 is, let's say, what is this? F of minus zero point 0.5, this number, 1.6. Okay?
Hmm.
Can you see this? Now tell me. Now tell me. F of minus zero point 0.4. What is that? Minus 1.5.
1.5.
F of minus zero point 0.2. What is that?
1.3 something.
1.3 something. Okay? F of zero point 0.1. What is that?
Of point 1
zero point 0.1.
near to 1.2.
1.2. Okay? So basically what we are trying to say, when x is approaching 0, we are approaching
1.25.
1.25. 1.25. That is what we are trying to say. Agreed, ma?
Yes, sir.
Okay. Okay. So, similarly, this one. This one, tell me. Both numerator and denominator are becoming zeros, right?
Yes, sir.
When both are becoming zeros, what do we do?
Common factor we
There
need
is
to
a
take.
common factor. What is a common factor? X
X
minus y should
minus
be a
5.
common factor. Okay. So if you cancel that out, then you will get 1 by x plus 5. Okay.
Yes, yes.
1 by x plus 5. So that should be 10. So wherever there are common factors, what you do? You remove those common factors.
Hmm.
Okay. X minus 5 by x square minus 25, whatever. If the denominator is becoming 0, Then if there is a common factor, you remove that common factor. Okay?
Okay.
Agreed. So in this case, what will you do? Tell me.
Take out the common factor. Like
Okay. So what are the common factors?
we can take out y first and then cancel it.
You can take in fact you can take y square also.
Hmm.
Okay. Remove y squares. Okay. The denominator is becoming zero because of lot of y's, right? If you
Hmm.
remove y square from both from the numerator and denominator, what will happen?
5y plus 8
By
by 3y square minus 16.
very good. So what does that mean? What is the limit?
So
What will become of the limit?
1 by 2.
1 by 2 minus what is this one? Minus 8 by plus 8 by minus 16. No.
So
So
minus 1 by 2.
minus 1 by 2. Understood? No.
Yes, sir.
Okay. That is how. That is how you have to do. Okay.
Hmm.
Okay. This one, what will you do? X tends to 1. So there is a hidden common factor, x minus 1, right?
Hmm.
You have to extract what is that hidden common factor. Understood?
Okay, sir.
So, okay, first if you draw the graph, what is this function? 1 by x minus 1 by x minus 1 whole of this by x
X
minus 1.
minus 1.
Okay, so if you draw the function at x equals to 1, he is given, right? At x equals to 1, it looks like, okay, now tell me, look at the graph. When the function is approaching 1, what is the value of the limit? Just by looking at the graph, tell me.
Minus 1.
Minus 1. Fantastic. Why? Because both sides we are approaching this minus 1. When I'm
Yes.
approaching the left or when I'm approaching from right, both sides you are approaching this minus 1. Okay?
Hmm.
Now how do you get this minus 1? There must be a common factor. So what do we do? Numerator, what you can write it? 1 minus x. You can send this x this side, right? 1 minus
Mm-hmm.
x and you
Yes, sir.
can do. Okay, just simplify that. Understood?
Yes, sir. Understood.
So what will be left? You'll be left with minus 1 by x or something, right?
Hmm.
Agreed, ma?
Yes, sir.
Okay. So, similarly 32.
Same way.
What you'll do? There
Do
is,
him
uh,
like get.
so 32 can you do and tell me what exactly is the limit?
1 second. 2 by x square minus 1,
2 by x square minus 1.
which
That's
is
what you're,
minus 2.
which is minus 2. Okay.
Hmm.
Okay, that's what you're getting. Now I'll try to plot the graph. Tell me, what is the function?
1 by x minus 1
1 by x minus 1.
plus 1 by x plus 1
1 by x plus 1
whole divided by x.
whole by x. This one only, no?
Yes, sir.
Okay. Now, what is the limit when x tends to? What is the question? X should tend to 0. Huh?
0.
X tends to 0. It is minus 2. Clear,
Hmm.
right?
Yes, sir.
Okay, graphically you are clear, no? So
Yes.
it is very important. Graphically you should be convinced. When
Hmm.
you are approaching from left, from right, you are approaching minus 2, right?
Yes. Yes, sir.
Very good. Fantastic. Now this one, how do you do?
Take u cube common. No, 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 no. So direct.
Hmm. So So what does it mean? U minus 1 is a factor here, right? Somehow you have to eliminate U minus 1 because in denominator is becoming 0 because there is an U minus 1, right?
Yes, sir.
Agreed. That part you agree, right?
Yes, sir.
So you have to somehow eliminate the factors that are making it 0. See, this thing roughly means this is U minus 1 into something. Otherwise, this will not become 0, no?
Yes, sir.
Okay, in all the cases, if something is 0 means somewhere, if some big expression is 0, okay, we
Okay,
can
sir.
roughly assume that as 0 into something. Okay, not very exact. If something is becoming 0, that means we can roughly assume that as 0 into something. Okay, it is becoming 0 because you are multiplying 0 with something. Okay, we can roughly assume that as. So what we are trying to do in these limits is we are trying to break that into 0 into something and removing that 0 part. Okay,
Yeah, okay, sir.
agreed. So this is in the form of a square minus b square. Okay, agreed.
Yes, sir.
This is in the form of a cube minus b cube. Okay, so there is a minus b common here also, here also. Agreed. So there is an u minus 1 common in both the cases. We try to remove that u minus 1. Okay, a square minus b square, a plus b into a minus b do in the numerator, a cube minus b cube, a minus b into a square plus ab plus b square that you do in the denominator. Okay, first try to simplify this, then I will plot the graph. Okay, or otherwise first I will plot the graph. Okay, first you tell me the answer looking at the graph. Just write this one, u cube a x power 4 minus 1 by u cube minus 1, right?
1 by u cube minus 1.
X
Yes,
power
sir.
4 minus
Minus
1
1.
by x
X
cube,
cube minus 1.
x cube minus, okay, x cube minus 1. Okay, this is the function we are talking about. Okay, at where is it? At x equals to 1, right? 1 or 0? X
1.
equals to, at x equals to 1, right? This one only, right? At x equals to 1. So what is it looking like? It is looking like some number like 1.3, 1.2, whatever. Agreed?
Yes, sir.
So what is the limit? You tell me, what is the limit when x tends to 1? What is the limit? Just by looking at the graph.
When x tends to 1.
Hmm.
1 point.
1 point something. Okay. When x tends to 0, what is the limit? When x tends to 0.
Not defined.
Why not defined?
So 1 is coming from minus infinity, let's say, and 1 is from plus infinity.
But both are approaching 1, no?
So you said for approaching to 0, right?
0. When x is approaching 0, what is y approaching?
Oh, okay. 1.
1. When x is approaching 0, what is y approaching? Again
1.
1. Okay. Whether it is coming from bottom, it is coming from top, it doesn't matter. Okay. They're still approaching this 1, no?
Yes, yes, sir.
Okay. It doesn't work in the case of this. You try to see the difference between this and this. Here x is approaching 0. What is happening in this?
Minus infinity.
Y is approaching minus infinity in this case, plus infinity in this case. So that's why it doesn't work. Understood?
Okay.
Okay. Or in this case, x by this one. In this case. What is the difference between these red lines and the green line? Tell me.
It's that
Hmm.
at 0, like when x is approaching 0,
Very good.
no fixed limit for it.
Understood, no?
Yes, sir.
In one case, in the green case, the at least we are sure that whichever side you try to go, you will reach this destination only. Okay. Whether you go from left, you go from through this road or through this road, you will finally reach this same destination. Agreed. But
Yes.
in the case of these red ones, you are not reaching the same destination. If you are following this path, you are reaching this destination. If you are following this path, you are reaching a different destination. Okay. So that's why limit doesn't exist. Okay. Limit means the destination should be the same. Whether you are following different paths, whichever path you follow, there are only always two paths.
Okay.
Okay.
Yes,
The
sir.
left path and the right path.
Yes, yes, sir.
Okay. There are always two ways of approaching. One from the left, one from the right.
Hmm.
If both paths are converging to a single destination, well and good.
Okay, sir.
Okay. If both they are not converging to a single destination, then that means limit does not exist. Okay.
Hmm.
Now coming back to our problem. Okay. Where are we? We are doing 34 or 33?
33.
33. Now simplify this.
Okay. So one.
You are getting one, right?
Yes, sir.
No, no, no. It should be when x is approaching 1, it should be 1 point something. Right?
Hmm.
Just check it is 1 point something or not.
Yes, sir. So you're saying graphically or
No,
answer
no.
based?
Both should you should get the same value. So here u square minus 2, u square minus 1 into u square plus 1. Right?
Yes, sir.
This is u minus 1 into u square plus u plus 1. Right?
Yes, sir.
Okay. So now this becomes this u minus 1 if you cancel, this becomes u plus 1 and
Hmm.
u square plus 1, right, in the numerator. That becomes 2 and 2, right?
Yes, sir.
U plus 1 and u square plus 1. Denominator becomes 1 plus 1 plus 1, 3,
3.
right? Put 4 by 3. That is 1.33.
Hmm.
Agreed?
Yes, sir.
Okay. So graphically also we are getting the same thing now.
Yes, sir.
1.33 something. Okay?
Hmm.
Agreed?
Yes. So 1 minute.
Ah.
Yes, sir.
Understood, ma?
Hmm.
Okay, next one. 34, it is looking like, so again, denominator, numerator both are becoming zeros.
Hmm.
That means v minus 2 should be a factor. Same problem. This just in the opposite way, right?
Yes, sir.
This again 2 power 4, v power 4 minus 2 power 4. This is v cube minus 2 cube. Okay?
Hmm.
You can do that, right? Same,
Yes.
exact same. 35, tell me.
So rationalize.
35, see, root x minus 3. This also you can write it like this, right? Root x minus root x whole square minus 3 whole square,
Hmm.
right? This root x minus 3 you can directly eliminate. See, x minus 9 is a factor. That means root x minus 3 is also a factor, right?
Yes, sir.
Okay, so we want to eliminate this root x minus 3. This one you can write it as root x minus 3 into root x plus 3, right?
So you'll be left with 1 by root x plus 3.
1 by root x plus 3, exactly. Okay, 1 by root x plus 3, what is that value? 1 by 3 plus 3, right?
Hmm. 1 by
Okay,
6.
Okay, so this one,
Similarly,
similarly, what you will do?
remove 2 minus root
You
x.
have to remove 2 minus root x. How will you remove 2 minus root x? How will you remove? You take common x here, 4
Hmm.
minus x will the numerator will become, right? X into 4 minus x. Agreed?
Yes, sir.
Now 4 minus x you can write it as 2 square minus
2.
root x whole square. Okay?
Yes, yes, sir.
Okay. Similarly, these ones you can rationalize the denominator, numerator, whatever.
Yes, sir.
Okay. So here what you have to do, you have to get x plus 1 as a factor in the numerator.
Hmm.
Okay. These are all those rationalizations.
Hmm.
Okay. These are rationalization. These are direct substitutions.
Yes, sir.
Okay. So what you do today in your textbook or wherever, you will
Hmm.
have this lot of these kind of rationalization problems.
Hmm.
Okay. Okay. Try to finish off those problems. Okay. And try to
This is an
see
NCRT.
where ma
This is an NCRT.
NCRT it should be there. I think this is not NCRT. This is a different book. Okay. This is uh, uh, this is some calculus book which is called Thomas Calculus.
Hmm.
Okay, this you need in engineering also. This is just the beginning chapter of the book. Okay,
Okay, sir.
okay, this is actually an engineering textbook. Okay, but similar kind of problems. I mean, the various algebraic techniques of factorizing this, that, and all. Okay,
Hmm.
here we are not using the L'Hopital rule. You know the L'Hopital rule, no? The differentiate numerator and denominator of this thing.
Yes, sir.
Okay, so we are not used that yet. Okay,
Hmm.
we are just using basic algebraic manipulations. Okay,
Okay.
we have not used even sine theta by theta kind of thing. Okay,
Okay.
okay. So try to do this algebraic manipulations. Okay.
Okay,
Now
sir.
another important thing I want to cover. Okay, sine theta by theta limit theta tends to zero. Okay.
Hmm.
Now the first look at the graph. Okay, I'll draw the graph sine x by x. Sine x by x. Okay. Look at the blue graph. How does it look like? What is the limit? Tell me. When x tends to 0?
1.
When x tends to 0, 1. But f of 0 is not 1. F of 0 is not defined, right? Sine 0 by
Yes, sir.
0. Okay. But it looks like it is approaching 1. Okay.
Hmm. Yes, sir.
Agreed. Now what will happen? Sine 2x by 2x. Let's try. What is this?
Again, it is approaching to 1.
Again, it is approaching 1. Sine 3x by 3x.
Again, 1.
Again 1. Let's say sine 3x by x. What is this becoming?
3.
What is this is becoming 3. Okay, basically, and sine 4x by x is
4.
becoming 4. Okay,
Hmm.
okay. So basically, sine theta by theta it approaches 1. Agreed. Sine
Yes, sir.
theta by theta. Okay. Now, when you say sine 4x by x, okay, what you do, you multiply both numerator and denominator with 4.
4.
Okay, this is sine 4x by 4x means what? This is equal to this, right?
Hmm.
Agreed. We are just
Yes.
multiplying numerator and denominator. But this part is 1. Agreed.
Yes, sir.
This part is 1 because this is sine theta by theta. So what is the value of this function?
4.
What is the value of this limit? This should become 4. Understood?
Hmm.
Okay. Sine theta by theta is always 1. Okay. To make it sine theta by theta, you multiply with other things. Whatever is extra, less, whatever, you multiply it with other things to
Hmm.
make this expression sine theta by theta always. Okay.
Okay.
This
Hmm.
is one important technique that you will see.
Hmm.
Okay. Now another thing. Okay. Keep it aside. Tan x by x. Okay. What is this? Now tell me. Tan x by x when x tends to 0. What is the value?
1.
It is 1. Okay. Now tan 2x by 2x. What is this value?
1.
Again 1. Okay. Tan minus 4x by minus 4. What is this?
Again, 1.
Again 1. It doesn't matter. Okay. Now, same with sine also. Tan 3x by, let's say, x. What is this value?
3.
It is 3. So what we are doing here? Here also we are doing the same thing. This is
Divide by
equal to
3.
multiply and divide by 3. So this part is 1. So total is 3. Okay? Okay. Agreed.
Yes,
So
sir.
this is one important result. Sin theta by theta is equal to 1. Tan theta by theta equals to 1. Okay.
1.
Now another important thing. Okay. I'll remove this 4. Okay. Sin theta by theta, tan theta by theta. Okay. So the another important thing is sin theta by theta. This is approaching 1 from the bottom. Okay. It's always lesser than 1. Agreed?
Yes, sir.
It is approaching 1. Okay. But tan is the opposite. It is approaching 1, but from the other side.
Hmm.
Agreed?
Yes,
Agreed,
sir.
huh?
Yes, sir.
Okay. That you agreed. So why this is becoming like this is if you plot the graph of x, okay, and if the plot graph of sin x, and if you plot graph of tan x. Okay. These three. Now I'm erasing these ones. Okay. If you see plot graph of x is this. Agreed?
Hmm.
Agreed? Sin x is always lesser than this violet line. Okay.
Hmm.
But it is getting closer. That's why this by this is becoming 1. Agreed?
Yes.
Whereas tan x is always greater than this one.
Hmm.
Okay. Okay. That is greater than this one. But this is also approaching from the upper side.
Hmm.
Okay. That's why this ratio is also closely becoming 1. Understood? Both ratios are approaching 1. This approach is actually 0.9, 0.99, 0.999 like this. This
Oh,
approaches. Whereas this approaches as 1.1, 1.01, 1.001 likewise. Okay,
understood.
both are approaching. That's why you are seeing this kind of graph for tan and this kind of graph for sine.
Hmm.
Agreed?
Yes, sir.
Understood? No?
Hmm.
Okay. So this is important. Okay. So the another proof of this is, let's say you take a small circle. Okay, circle of radius 1. Okay, this
Hmm.
is a quarter circle of radius 1. Okay, this is radius, and what is the height?
Sine.
R cos theta is this one, R sin theta is this one. R is
Hmm.
1, so that's why this length is sin theta. Agreed?
Yes, sir.
This length is cos theta. Agreed?
Yes, sir.
Okay. Now, if this is radius, this is theta. Theta is in terms of radians. Okay. What is the length of the curve? R into theta, right? This curve,
Hmm.
R theta. But R is anyway 1, so length of this curve is theta. Agreed?
Yes, sir.
Okay. PA. Now, this line, okay, is always shorter than this curve. Agreed?
Yes, sir.
Okay. No. Forget about that. Uh, this area of OAP, this this triangle area.
Hmm.
Okay. This triangle area is lesser than this sector area. Okay. Because there is this part extra, right?
Hmm.
This triangle area is lesser than this sector area. What is it? This triangle's area? Half base into height. Half this base is anyway 1 because this radius is 1, right? Into
Hmm.
height. Height is what? PQ. PQ is nothing but sine theta. Okay. Half 1 into sine theta is half sine theta is the area of this rectangle. Agreed?
Yes, sir.
This entire rectangle. Which one? This rectangle. OAP. Okay.
Hmm.
This is lesser than the area of this sector. What is the area of this sector? Half r square theta.
Yes,
Agreed?
sir. Hmm.
R square theta. R is again 1 and theta is theta, half theta basically. Okay.
Hmm.
And what is the area of, there is a bigger rectangle. Okay. Okay,
80.
this is theta, and this is theta, and this is 1. Obviously, this should be tan theta. Agreed?
Hmm.
Okay, this by this should be equal to tan theta. Right? That's why because this is 1, this is tan theta. So half base into tan theta. Right? That is the area of bigger triangle. Right?
Yes, sir.
Okay, the smaller triangle lesser than sector, lesser than bigger triangle. That's what we are saying. Okay,
Hmm.
half sine theta lesser than theta by 2, lesser than tan theta. So effectively what we are saying, sine theta is always lesser than theta, which is always lesser than tan theta.
Hmm.
That is what this graph is about. Okay, sine theta is lesser than x, which is lesser than tan x. Okay, that's what we are
Yes.
trying to say. Sine theta is always lesser than theta, which is lesser than tan theta. Okay,
Hmm.
that is this point. Okay, now what we are doing, we are dividing everything with half sine theta, all three. Okay, 1 less
Hmm.
than theta by sine theta. less than tan theta by
1.5.
sin theta, which is becoming cos theta. Okay.
Hmm.
Okay. Now, if we invert this, what will this become? 1 greater than sin theta by theta, which is greater than cos theta. Agreed?
Yes, sir.
Okay. When theta tends to 0, cos theta tends to 1. Agreed?
Yes, sir.
Okay. Theta tends to 0, cos theta tends to 1. But what we are saying, cos theta is tending to 1 from the bottom. That means from lesser than 1, right? 0.9, 0.99 like this. Okay.
Hmm.
So this what is always lesser than 1, but still always greater than 1. And this is getting closer to 1 as theta tends to 0. So that means this one should tend to 1. That is the proof.
Understood.
Understood? Understood. By sandwich theorem. What we have told in sandwich theorem, if a function is lying between two different functions and both are approaching the same value, obviously this one should approach the same value.
Same
Agreed?
value.
Okay, cos theta is approaching 1 when theta is approaching 0. And this one is always lesser than 1. So obviously this one should approach 1.
1.
Okay, so that's why sin theta by theta is actually equal to 1. Okay, so you'll remember this, no? Sin
Yes,
theta
sir.
by theta, tan theta by theta, they will approach 1 when theta is approaching 0. Okay, ma?
Yes, sir.
Cool. So we'll stop here. What you do, there will be, you'll find some these questions also, questions like this. Okay,
Okay.
where you have to break this using sin theta by theta concept. Okay,
Okay.
sin theta by theta concept or cos theta by tan theta by theta, these kind of concepts.
Hmm.
Okay, try doing these problems also. Okay,
Fine, sir.
okay, with rationalizing cases and this sin
And
theta by
factor
theta concept.
equations.
So you'll will be left with this L'Hopital rule concept that we will discuss later. Okay.
Okay, sir.
Okay, these kind of things, they will give some explanation. If you don't understand, that is fine. Just we'll discuss that again. Okay?
Yes, sir.
Okay, Amma. Then take care.
Sir.
Bye bye.
Yes, sir.